Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Talk Radio 702 and 567 Cape Talk. The Naked Scientist.
The Naked Scientist is brought to you by The Rand Show. It's showtime, 18th to 28th of April at the Expo Centre, Johannesburg, Nasrec. Good morning to you, Chris. Welcome.
Hey, good morning.
Thank you very, very much. You have a fascinating story. I tried to read about it. It's going right over my head. Please break it down for me.
Well, it's a story all about Saturn and one of its moons called Enceladus. And this moon was actually discovered in the 1700s by the astronomer William Herschel. But it was only in the last 10 years or so that scientists made an even bigger discovery about it, which is it's home to quite possibly the biggest geyser, or geyser, depending upon how you say the word, in this solar system, because issuing from the south pole of this tiny moon is an enormous periodic jet of water. It's icy water and ice crystals that go thousands of kilometres away from the moon's surface into space. They even give rise to some of Saturn's moons. And scientists have therefore speculated that there must be some watery reservoir inside the moon, which is the origin of this spurt of water. Why does it happen? Well, because the orbit of Enceladus isn't completely circular around Saturn, it's in a sort of egg shape or oblong. This means that at various points in its orbit, Enceladus is being stretched and squeezed by the gravity field of Saturn. And this gravitational massage causes frictional heating inside the moon. And this liberation of energy, we think, drives these periodic plumes coming out. But scientists had no formal proof that there must be this internal reservoir of water inside this moon, which is just a tiny icy marble. It's just 500 kilometres across. It's very, very small. But now they've used some data from the Cassini mission. A Cassini probe arrived in the vicinity of Saturn in 2004, and it's done lots of flypasts to various aspects of the Saturnian system. And on a number of occasions, it's gone very close. In other words, under 100 kilometres from the surface of this tiny moon. And researchers on Earth have been able to watch the trajectory of the probe, and as it goes past the surface of the moon, they can work out what sort of gravitational force the moon is applying onto the spacecraft by tracking its trajectory. And if you know how the gravity field varies around the moon's surface, you can infer what must be inside it. And there is a funny anomaly on the south pole of the moon, which can only be accounted for if there is an ocean there. And so there's a paper in the journal Science this week. It's by Luciano Less and his colleagues. He's at the Sapienza University in Rome. Mm-hmm. And their suggestion is, and their model suggests, that inside Enceladus, in the south pole of this moon, there is an ocean which is 10 kilometres deep, spreading over at least half the lower pole of this moon. And it's that ocean which is probably the source of these plumes that come out. And the fact that you can have liquid water on something which is so far from the sun and otherwise so freezing cold owing to this heating effect says that, this is potentially a good place for life to hang out too, isn't it?
Wonderful. Thank you very much, Chris. Our lines are open for you. Give us a call, 021 446 0567, 011 883 0702. Chris, I have a question. I mean, we've got parts of South Africa that have no tap water, no running water, and people depend on the local rivers and streams, and sometimes the water is not clean. What is the most efficient way for households to purify their water? Uncomplicated, not expensive. Is it even safe to just take water straight from a river for household usage? What is the process of purifying it?
It depends on the river. Okay. If you are in an area of the world which is sparsely populated, then it's very unlikely that there's going to be anything in the water of human origin, which is going to pose a risk to you, because most of the people that die from drinking contaminated water around the world, and the numbers are big, it's 5,000 people a day, most of them children, because of something they drank. Most of the time they're dying of things that they caught, because there's been a contamination of drinking water with human waste. And where there are lots of humans, there are lots of bugs that can kill humans, and that's why we're our own worst enemy in that regard. So staying away from other people is a really good idea. The other thing to be aware of is that if the water has flowed near a source of some kind of poison or toxin, then although the water may taste great, may look great, and it may not have microorganisms in it, it may nonetheless contain very toxic levels of certain things. Areas where mining has been carried out, for example, can impart heavy metals like zinc or lead. There are also other chemicals that can get into the water, like mercury, for example, which can be extremely bad for you. So you have to be very careful to consider those aspects too. But if that isn't an issue and it's purely one of making sure the water is clean to drink, the first thing to do is to filter the water. A fine filter which can extract microorganisms is a good idea. Cholera is a rampant disease in some parts of the world, and it's actually a bacterium. It's caused by Vibrio cholerae, a bacterium that lives in the insides of a tiny, almost like a shellfish, a thing called a coccolithophore, a zooplankton in the sea. And if you filter the water to get those out, then you can't get the cholera bacteria into you, and that stops outbreaks of cholera. So filtering with a fine mesh can help. Then there are these sterilising tablets which use things like iodine, which impart iodine into the water, or chlorine, and this oxidises microorganisms to death. That's a good idea. It can also deal with some viruses as well, and so that's a good idea to make sure the water isn't contaminated. And then another good idea is to boil water, and if you boil water, most microorganisms won't be able to withstand the high temperature, and therefore it's a good way, if you don't have access to sterilising tablets or fine filters, you can also achieve water that probably won't poison you with microorganisms. But none of those things are going to get rid of potentially heavy metals and things like that. So you need to be really cautious about where you get the water from.
Yeah, true. Is it Mike? Mike in Midrand. Hi.
Hi, good morning. I'd like to know, speaking of the moon there of Saturn, how much sunlight would that actually get? Because I've been looking at the images that Cassini has, come from Cassini, and it looks quite nice. But if you were sitting at the orbit of Saturn, would the sun be noticeable? Like, would it just be another star? Or would you actually notice if it's really big?
Oh, no. I mean, relative to us, of course, the sun, it looks enormous because relative to us compared with the star, although the sun is a star, the sun is very, very close to us. The next nearest star is a very long way from the Earth, light years away. And for that reason, relatively speaking, the sun is going to be the brightest light source in the sky, whether you're here or actually a bit more distant. Once you're out at Pluto, it's a bit more up in the air. That's, of course, 6 billion kilometres away, but Saturn's about halfway there, and so the sun will still appear as a very bright object in the sky. Enceladus is easy to spot, despite its minuscule size, because it's effectively an icy marble. And the reason William Herschel was able to spot it is because it has this beautiful, shiny, icy veneer. It reflects almost all of the sunlight that hits it, which A, keeps it very cold, but apart from on the interior, as we've discussed, but B, it means that lots of that incident light comes bouncing back and we can see it, which is why he was able to spot it.
Thank you very much. Lovely question, Mike. Rick, Tobile and Puti, I see you all coming up right after this.
Talk Radio 702 and 567 Cape Talk. The Naked Scientist.
021 446 0567 or 011 Puti in Johannesburg.
Hey, Rudy.
Yes.
Simple question. What causes motion sickness and what one can do to prevent it? Because, it's killing me right now.
Motion sickness.
Hello, Puti. Good question. Motion sickness is not a new phenomenon. In fact, it was described hundreds of years ago by Erasmus Darwin, who is an ancestor, I think he was the uncle of Charles Darwin. And he described a phenomenon called mal de débarquement. And this was, or is, the characteristic sort of feeling you get when you get off an aeroplane or a boat, and for about a day afterwards you still feel like you're on the aeroplane or the boat. Everything appears to be moving around. And that's a hint at what causes motion sickness. We have in our ears, specifically in something called your inner ear, a series of tiny passageways called semicircular canals. And they resemble little circles or tubes in a circular shape. And they're all organised at 90 degrees to each other. And the point of them is they contain a fluid, and when you move your head around, then the fluid gets left behind transiently before it catches up with the bones around it. And this pushes on tiny hairs projecting into the liquid, and those hairs fire off nerve impulses to the brain, telling the brain which direction you're moving in and how rapidly. And normally, because we're all sitting still and we make incidental movements, then the brain can predict what we're doing at any one time, and it compensates by moving our eyes in the opposite direction. It keeps our muscles at the right tone to keep us balanced, and everything is in sync, and we feel happy. When you are suddenly put into a position that you're moving all the time, you've got continuous stimulation of this system, and your brain can become really quite confused, because unlike the normal stable static situation you're used to, this is departed, and now you've got these continuous movements going on. And for some reason, and we're not entirely sure why, the brain interprets this as an upset that it seeks to resolve by making you throw up. It doesn't seem the most logical way to go about things, but that's exactly what happens. And in some people, it's more pronounced than others. And you can treat it, though, because there are some drugs, especially antihistamine drugs, which block some of the nerve pathways that are used to trigger or stimulate or send these signals concerned with feeling sick, and so they do make some people feel a lot better. There are also other conditions that can lead to an enhanced experience of motion sickness, and they can be, again, attributable to the middle ear, or the inner ear, rather, having a problem. So, it might be one of those conditions. If this is suddenly new and acute, it might be worth seeing a doctor who can have a look and see if there's a new problem in the inner ear.
Thank you very much, Puti. Good luck to you. That sounds very unpleasant. Tobile in Arcadia. Hi there, Tobile.
Hello, guys. How are you doing?
Good. Yeah. Your question?
I just want to know, is it perhaps possible, right, to launch solar panels in outer space and then in turn have cables connected down to Earth for electricity generation?
Hi, Tobile. It's a good idea, but unfortunately, at the moment, with the materials we have, totally impractical. Because the cable, if you think about it, would end up being about 100 miles or 150 kilometres long at least, and it would therefore be extremely heavy. The drag on the air would be extremely high, and therefore you'd have something which was mechanically extremely difficult to do. But scientists are trying something else instead. One idea is to put some giant solar arrays into space, collect energy from the sun in those solar arrays, and then turn it into a form of energy that you can transmit more easily than electricity. And in this case, a group of Japanese scientists are trying this with microwaves. So you send down a big beam of microwaves from space. You then have a collector on the Earth's surface, like a giant dish, which gathers the microwaves, concentrates them into a central collector, and then you convert the energy in the microwaves back into useful electricity that you then distribute on the Earth's surface. And it sounds a bit dodgy, because you think you've got this microwave beam coming in from space, but actually the idea is to spread it over such a big area that the amount of microwave, or the density of microwaves in any given volume of the air, would be relatively low, and therefore even if you flew your aeroplane through this beam, you wouldn't be zapped.
Thank you very much, Tobile. Let's see who came in first. It was Eugene in Lyndhurst. Hi.
Good morning. Oh, I'm really happy to speak to you, the Dr. Scientist. I'd like to ask a question regarding, the volcanoes and earthquakes. I've just been sort of cross-thinking that I'm going to read what I wrote. I've always considered the world as being a very solid lump of rock, okay? And most people consider this. But lately I've rather think it's more like a mushy, deflated soccer ball with the tectonic plates resembling the hexagonal patches on the pattern of the outside of a soccer ball, which are held together by stitches, So if we think of the tectonic plates of the Earth as big patches, I now think that if we consider the stitches of the tectonic plates as resilient joints, is it not reasonable to assume that the lunar and solar gravity pull actually can dislodge the tectonic plates? So that's the main thing, is the effect of gravitational pull of the solar and lunar. And maybe these cause the earthquake. And maybe even accelerate the frequency. In other words, the world is becoming softer as these events take place at the subduction zone.
All right, I think we get the gist of what you're arguing, Dr. Chris.
I don't think that we would say that the Earth is becoming softer. If anything, the Earth is cooling a little bit, although very slowly, thankfully, and this means that it is not going to congeal any time in our lifetime anyway, anytime too soon. But certainly it is cooling down a little bit, so it will become stickier. In terms of the idea about the tectonics, certainly the tectonic plates and the interactions and interfaces between them are what causes these fault zones, and fault zones, owing to the movements of plates, store energy in the fault and then will release that energy at some time in the future, and this release is what we call an earthquake. Whether or not that can be triggered by events like gravitational attraction from or interaction with other bodies, certainly I don't think we know for sure, but it's certainly true that the movement of mass or redistribution of mass around the Earth's surface definitely is linked to the initiation of earthquakes. And the evidence for that is that scientists in Taiwan did a study a few years ago where they were able to measure the changes in faults in relation to the weather. And you'll see where I'm going with this in a second. Mm-hmm. So they put these very sensitive measurements and strain gauges on faults in Taiwan. They then recorded what the weather was doing, and they found that when there were big storms, they were also more likely to have faults opening up and then ensuing earthquakes. What's the connection here? Well, when you have a very big storm, you have areas of very low pressure. And when you have areas of very low pressure, you have a very big movement of water to the low pressure area. So the sea level effectively comes up because there's less pressure pushing the sea out of the way. And with the sea coming up, you've got more mass. And if you've got more mass, you're pressing on the Earth more. And if you're pressing on the Earth's surface more, you're more likely to load or unload faults. And so what they found is that this movement of water was loading and unloading faults and triggering earthquakes. And therefore, given that the moon drives the tides because it pulls water around the Earth's surface towards itself as the Earth rotates inside the moon's orbit, then it's possible that that distribution of water will in turn load and unload faults, and this is going to potentially potentiate or exacerbate earthquakes. What I will say against that, though, is that because this is happening all the time, every day, day in, day out, with high tides every 12 hours, then it's very unlikely that this is going to lead to very much energy building up in a fault, because if that's the driver, you'd have not very much energy between high tides to accumulate. But it might be that these things do, over time, help to trigger a fault that's already at breaking point to suddenly go and trigger an earthquake. So I certainly think that there's a possible interaction there. Although, if any geologists know better, please come back to us and let us know.
Of course. Rick in Cape Town, you've been so patient. Welcome.
Hi, Ree.
Hi there.
Can I ask my question?
Yes, go ahead, please, Rick.
Chris, very great to speak to you. I've got a question about the Big Bang. Until recently, it seemed that the Big Bang was a theory, and just had a theory proposed by Albert Einstein and fine-tuned by people like Stephen Hawking and Professor Linda and so on. And about 2 weeks ago, there was an announcement of observations made in an observatory in the South Pole that they found real evidence that of echoes of the Big Bang in the form of gravitational waves. My questions are, what are gravitational waves, and how do they provide evidence for the Big Bang?
Okay, I think we did touch on that about
Hello,
2 weeks
Rick.
ago. Yep.
Right, well, interesting. I was having this very conversation with a gentleman at Cambridge University where I work just 2 days ago, because he was trying to build the same experiment that made this discovery about 5 years ago, and he would have probably made the same observations years ahead, he says. But there you go, he would say that, wouldn't he? But he probably would, actually. And what the BICEP, B-I-C-E-P, BICEP 2 telescope in Antarctica was able to spot, they were looking at what we call the cosmic microwave background radiation. The cosmic microwave background radiation is light or energy left over from the Big Bang, which, because the universe has expanded enormously in the time that it's been in existence, for about 13.8 billion years, the light, which was originally very short wavelength, high frequency, has stretched out, and it's now in the microwave regime at a frequency of about 100 to 160 gigahertz. And that light can be detected even today bouncing around in the universe, left over, and that's why we call it as echoes of the Big Bang. But because it was produced at a time from when the Big Bang happened, scientists have been very interested in it because it basically contains information which we can use to inform our models of how we think the universe formed. What the BICEP 2 telescope was able to discover, according to Clem Pryke, one of the authors of the study, which was published a couple of weeks ago in the Journal Archive, what they say they can see is ripples in this microwave background radiation when they sample it at certain frequencies. They used, I think, 150, 160 gigahertz. They can see these ripple patterns. Now, the only way you can explain these ripple patterns is by gravitational waves. And when the universe first popped into existence, in the first 1/1,000,000th of a second, there was enormous amounts of energy which were turning into mass. And as this mass or matter or material was being made, then it was issuing gravity waves which were influencing the behaviour of the way the universe was growing or inflating. And that therefore tells us that this period of inflation, which is in our model for the origin of the universe, must have happened. And by unpicking the patterns of these waves, how they basically twisted light, gravity can cause light to twist, and that's what they're seeing, this twist or polarization of the light. This tells us a lot about that very early phase of the universe, how intense energy began to get converted into matter. And that's why people are so excited about it, because it sort of begins to give us an insight into something we previously couldn't probe about where we all came from.
Thank you very much, Rick. And Darren, I think we do have time for your question. Darren in Norwood, hi.
Yes, hi there. Sorry, I've got a bit of a morbid question. I need to find out if you exhumed from the cemetery a few graves of people that had died in the early 50s, and they had diseases such as the bubonic plague or smallpox, leprosy, or even, I think there are dogs buried there as well that had anthrax. If they exhumed those graves now, would there be any risk of these diseases being airborne, and or if they'd found, let's say, needles from treating those patients in those days, would there still be a risk?
Okay, morbid but fascinating. Yeah.
It certainly is fascinating. I think the answer is the risk is really small. The majority of these microorganisms, once the host organism is dead, those microorganisms don't have a very long persistence time in the environment. That's not to say that all organisms are like this. There are some viruses, and the smallpox virus is extremely resilient. The virus that causes foot and mouth disease in animals is extremely resilient, and people are finding microorganisms that have been frozen in permafrost and remained viable for thousands of years. So if your body was frozen in ice, then it's perfectly possible that microorganisms of the resilient type we've outlined would remain viable. And in fact, the influenza 1918 Spanish flu strain, has been recovered and brought back to life from bodies and body parts from permafrost. They didn't actually recover active virus, they recovered the genetic sequence of the virus that way and were able to piece it back together and make viable virus. But it shows that potentially other organisms that are a bit more resilient than flu could survive that. So depending upon the conditions where the body is stored, I'd say the odds are in the short term it's highly likely you could get something back. If the bodies were stored in a hot country in harsh conditions, it's very unlikely that anything infectious would survive. And when it comes down to things like viruses on needles and stuff like that, once the needle has dried out and been exposed to sunlight and dry hot air, most of these viruses deactivate really quite promptly under those circumstances. I wouldn't advise you to take risks, but it's likely that you're not going to catch anything off of something like a needle that's been hanging around for a month or so.
Chris, we look forward to seeing you in 2 weeks' time, and have a lovely weekend.
Oh, I'm looking forward to it very much, very much. It's going to be great fun.
Absolutely great. We look forward to that. Very excited. Already getting inquiries from people wanting to be part of our studio audience. We'll let you know how you can achieve that.